This is a review for Chapter 3, which is on integers. Question 1 of the review is going to be what is the best integer to use to represent the depth of a lake that is 47 feet deep? So here's our lake. And it has a depth of 47 feet. And we would want to use negative 47 as the integer for that, because usually we'll have up as positive, down as negative, and the surface of water is usually 0. If we're going down 47 from the surface of the water, it's negative 47. That would be the appropriate number for our situation. Okay. Question 2 is going to be, we want to know a number that is less than negative 52. And so if this is 0, here's 52 over here, and here's negative 52 over here. Less than is that direction. We want something that is further away from 0 than 52. So, for instance, negative 53 would work, or negative 100 would work, or negative 1 million would work. But you'll be expected to know how to find numbers that are bigger or smaller than positive numbers, like 52, and numbers that are bigger or smaller than negative numbers, like negative 52. We want you to be able to put numbers in order. If you're given 5 numbers, some of them positive and some of them negative, you'll have to put them in order from smallest to biggest. Let's say we have negative 3, 0, 10, negative 6, and 7. Almost look terrible. We want to put them in order from smallest to biggest. First off, all of the negatives are going to go on the left side of 0. 0 is going to divide all of our positive numbers from our negative numbers. So now I've put 0 where it goes. All of the positives are after it. All of the negatives are before it. I look at the negative numbers. They should count down to 0. So negative 6 is further away from 0 than negative 3 is. So it comes first in our list. And then all of the positive numbers are put in the normal order that you are used to. Like that. Okay. Let's get our next question. So, if I have a bunch of negative signs, and I want to know what does it simplify to, what you're going to do is you're going to take every pair of negatives and cancel them out. If you have no negatives left over, your number is positive. On the other hand, when I pair up, that's a pair, and that's a pair, and I get rid of those. If you have a negative sign left over, your answer will be negative. With absolute value bars, first you take care of the absolute value bars. They count as parentheses in the order of operations. So this absolute value of negative 7 turns into just positive 7. I attach the negative sign to the outside. If I have something like this, I make the number positive, but it already is. So This part here becomes regular 5, and then the negative gets applied to it. So the absolute value does not just switch the signs, it switches the sign to positive. If it's already positive, it leaves it alone. Okay. By the way, now that we can put absolute values inside of equations, we get things like this. We ask, what's the solution? What does x equal? Well, if x is positive 17, the absolute value of positive 17 is 17, and that's a solution. But if I plug in x is negative 17, the absolute value of negative 17 is also positive 17. Both of these are solutions to this equation. On the other hand, if I have the absolute value of x equals a negative number, absolute values are never negative. There is no solution to this. There is no number that makes that a true statement. Though you can make an absolute value equal to 0. That means that the solution will be whatever makes the inside of the absolute value equal. Okay. We should be able to add and subtract positives and negatives. Maybe we have something like 5 plus negative 2. We should understand that when these signs are different, we are subtracting. So we get 5 minus 2 is 3. When these signs are the same, that is, this sign and this sign are the same, then we are adding. So we get that. Let's say what happens if we have a negative. If I have like a negative 15 minus positive 30, this simplifies to be negative 15 minus 30. And we have a negative, and we are taking something away from it. So we are at negative 15, and we're going 30 this way. And that will end up at negative 45. So I guess when I said if these signs are the same, we're adding, and if these signs are the same, we're subtracting, it's true when you have the signs next to each other. Like this. This is a subtraction. This is a negative. On the other hand, this symbol and this symbol are not next to each other. For that, we say if the two signs are the same, we'll use our addition algorithm. 30 plus 15 is 45. But since we're adding negative numbers, the answer we get is negative 45. Okay. We should be able to do subtraction with these as well. I don't know why 14 and 10 are stuck on my. Let's change that. Okay, so let's have 14 minus negative 12. These negatives are next to each other. That means that we are adding. 14 plus 12 is 26. That's not too bad. Okay, let's have a word problem. So let's suppose a 22-year-old student has 120 in their bank account. They're charged $50, then charged $30. Then they return a $15 item. What's their balance? Well, we want to know what the goal is. We want to know what the balance of the account is. So then we're going to go through and say what information is useful. Age is not, starting balance is, anything that changes the balance is, and then it's important to know which balance changes are going to be positive and which ones are going to be negative. If this is the starting value, and it doesn't say it's a debt, it says that they have that much money, this will be positive. On the other hand, withdrawals and charges are going to be negatives. The return is going to give a credit, which is going to be positive. So we write this as 120 minus 50 minus 30 plus 15. There are lots of ways we could do this. Your textbook says to add up all the negatives and add up all the positives like this. So 120 plus 15 is 135. Negative 50 minus 30 is negative 80. And then we combine those at the end and get 55. But I think that just going left to right and pairing things up is better. So, same problem. Actually, the best way is matching up things that are going to get nice cancellations, but this is decent enough. This is going to be 80. This is going to be negative 15. So we get 80 minus 15 is 50. If you do it the way the textbook says, you're going to end up with the biggest possible numbers you can while doing this in some sort of reasonable way. If you do it this way, you're going to have smaller numbers, maybe not the smallest numbers and maybe not the roundest numbers, but you're not going to maximize the size of the positive and negative chunk and then force yourself to add and subtract as big as possible. Okay, so move on to multiplication and division. We have 6 times negative 4. We have opposite signs. We get a negative answer. If we have multiple numbers, then we can pair them up. This has one negative sign, so negative 36. This has two negative signs, so it's going to be positive 6. And then 6 times 6 is 36. 6 times 3 is 18, plus 3 is 21. And we have a negative sign, so there's our answer. Your numbers won't get as big as 3 digits, but c'est la vie. Okay. With exponentials, we have this problem here. This one means do the exponent first, and then do the negative sign afterward. This one means the same thing as this, and that means that we'll cancel these negative signs in pairs. There are two, so they both cancel. So this way gives us a negative because this negative is applied afterward. Do the exponent, make it negative afterward. This one, in this case, we get positive because we had two negative signs and they cancel. If we have something bigger, like this, we have -2, -2, and -2. The negatives pair up and cancel. 2 times 2 is 4. But then we have a spare negative sign that makes the answer negative at the end. We have to remember that 2 divided, sorry, not 2, that 0 divided by anything is 0, but anything divided by 0 is undefined. We may have used, this is okay. That one's a knockout. Bad. Don't get knocked out. Okay and KO'd, right? The division rules for positives and negatives work the same way as for multiplication. So if I have a negative divided by a negative, I get a positive. If I have a mixture where one is positive and the other is negative, I get a negative. So both are negative, gives me a positive. One is negative, gives me a negative. This we should know how to do positives and positives. So like 6 divided by 3 is 2. Positive, positive, those are the same. We get a positive. Same sign gives us positives. Different signs give us negatives. We should remember order of operations. So if we have something like that, this is in parentheses because absolute value bars count as parentheses. The absolute value of -3 is +3. Then we attach the negative sign to it. Inside these parentheses, we have these parentheses. Do those first. -7 minus 3 is -10. 3 times -10 is -30. This is not the most efficient way to do it, but it is the way that follows the order of operations closest, and so it's for people who are more hesitant about math, it's the easiest way to get through it. -30 divided by -3, we have negative divided by negative gives us a positive. 30 divided by 3 is 10. -3 minus 10 is -13. Go. We have to feel good about our our word problems, the Polya steps are still like really good ways to figure out how to do our word problems. We want to make sure that we know the goal. I think that that's 1A. 1B is to sort relevant I wish I could spell. Sort relevant and irrelevant information. 2A. Oh, 2 is just plan. 3 is to do the plan. 4 is to reflect. That comes in 2 forms. One is check reasonability. And B is to try and sum up what the lesson you learned was. So think about how to do the job more effectively in the future. What you learned, how to do this better in the future. So let's try a word problem. We have I'm going to just make up numbers. These years and this data is not accurate. I'm just making up numbers for the problem. So Provo was founded in 50, and Salt Lake City was founded in, this would have been 1847, I think it's correct. The temperature in Provo was 77 degrees. Temperature in SLC was determine the difference temperature between Provo and City. What information is important? Well, the stuff about temperature. We don't need to know the dates, but we do need to know temperatures. So that's all we're asked to do. Without solving the problem, we're supposed to identify which numbers are useful and which ones are not. Circle the ones that are useful. We have a few problems like this. You sort out what information you're. So we have a few problems where you're not solving the whole problem. You are practicing sorting information. You have a problem like that. You have a problem where you will write out the equation you need to solve the problem, but you won't actually solve that equation. And then there's going to be a reflection question where you will check to see if the answer you got is correct or not. And by the answer you got, I mean the answer that was put on the test. You'll be given a question and said a student answered this, and your job is to figure out did the student do it right or not. And then you will have one question that will do all four of these things, dealing with positive and negative numbers. You'll have to add, subtract, multiply, and divide positive and negative numbers, starting with figuring out what information is actually useful in the paragraph that you read, writing out an equation or a statement, like an expression, that will solve the problem, doing the plan, meaning solving the equation or simplifying the expression, whichever you chose to do, and then checking to see if it's reasonable. Okay? So, that is quick 25-minute review of the test. Best of luck when you take it. I think you've been working hard this semester, and I am excited to see you succeed in this. I will see you class. Next class will be a few days from now. Okay. I'll see you then. Good luck. Bye.